Well, welcome to my talk. Thank you for joining us after lunch. And when I suggested this topic, I had no idea they would schedule me after a panel of 4 distinguished authors and thinkers on this subject. So, but I think we're going to have a little fun and get this thing so that it is relevant to the Mars Society members. How many are Mars Society members here? Okay. Pretty much all of you, and that's good. So a little background on me. My name is Mohsen Marefat. I'm an electrical engineer by trade. I've had the privilege of working with fantastic engineering teams at NASA, IBM, and then a plethora of startups. And I am a founder of a company that helps startups with part-time CXO type skills, as well as raising money for them. And sometimes I dip my toe into the technical matters and have fun as one of the developers. So that's great. But you wear many hats. In 1998, I was involved with a MIT and Harvard group of kids whose job was to develop a business plan for exploration of Mars. So I went to the MIT Mars Week, which is an annual event they do in the fall. I met Dr. Zubrin, learned about Mars Direct, and ever since I've been a member of the Mars Society. In more recent times, I have developed a talk that I call Mars 101. I gave a brief version of it last year at this convention. But it's about a 45-minute to an hour talk, and I've given it to audiences as diverse as a retirement community, faculty and graduate students at an engineering school, and all kinds of different people. So the one thing I can report to you is people are interested in the topic. They pay attention and they ask questions. So that's very, very encouraging. Somebody mentioned yesterday in one of the panels as the best way to clear a room in a party is to start talking about Mars exploration. That has not been my experience. People are interested. And because there's a plethora of information, it's actually very helpful to distill things down to clear ideas and communicate them in a way that people understand. So in this talk, I actually cover fundamental topics, the differences, similarities of Earth and Mars. And I'm very proud of myself. I do a 2-minute description of orbital dynamics and rocket science. And then I ask people, did you get it? And then the issue of what to look for, which gives us the topic of exploration. I don't use the term exploration lightly. And I'm not, in this, I want to focus on not the far future, not one-way trips to Mars or colonies, all that. A city on Mars would be fantastic, but this discussion about the technology we have available, the next few things we can develop, and go on and explore. And to explore correctly, you need to frame your questions correctly as best you can. So that brings us to today's topic. Among the people I talk to, my favorite audience is like the junior high kids. And I very often ask them, what does our galaxy look like? Sometimes you get garbled answers, but a lot of times you get, it's a disk-like structure with spiral arms. Then I ask them, how do you know this? How do we know this? And a lot of times they tell me they've seen a picture or a video. And now I have to step back and ask them, where do you think the camera that took that picture of our galaxy is? Okay. So that's always a step into this conversation. It's like jujitsu. And indeed, we don't know if our galaxy is a neat spiral like that. We can speculate by looking outwards. This is like a composite of Sloan Observatory Digital Sky Project that looked for perfect disks. And there's 53 of them in this. Only a couple are angled correctly for our observation. And we can surmise that, hey, ours may be like this too. Indeed, we're sitting on the edge of this spiral, and it's hard to see the whole picture. So we have to develop models. And modeling and simulation is what I've done as an electrical engineer and a control systems engineer. When you learn how to model a system, then you can do a lot with it, because now your knowledge of it becomes very deep. This kind of modeling is going to be at the core of our exploration. So in today's talk, I want to concentrate only on 3 topics. They scheduled me after that distinguished panel, and if you were all there, you noticed that the great thinking abilities that we all possess, and in a community like the Mars Society, we tend to meander at times, right? We ended up beer on Mars and porn on submarines. And the essence of talking to people, you have to be concise. You can't take, a long time to go through this. So I've had to take this dialogue and really distill it to these 3 topics: best use of resources, suitability to the task, risk-reward analysis. In operations management, where it's a big company's manufacturing or a small startup trying to raise funds and do R&D, you deal with the same issues. So for me, in order to model a complicated question like Mars exploration, and is it worth doing, is it risky to do we have the capabilities, requires me to develop a perspective, a framework, if you will, to do this. And that's really the question of where's that camera? Fantastic picture. The camera, I consider this a terrestrial picture of Mars, although the camera is in orbit on board the Hubble Space Telescope. This one is a real observatory on Earth, I think pretty close to here. I think back to the first telescopes. Galileo and Tycho Brahe had these very primitive telescopes. Immediately, they aim it at what they call the wandering planets. Famously, Galileo observed Jupiter and 4 moons, and he took consecutive observations over a period and noticed that they're rotating. The small objects were rotating around the big guy. And of course, he had heard about the Copernicus model, which was controversial, a book that had been banned. But once you see that yourself, you can't put the idea out of your mind. And he couldn't, and he got in trouble. Right? But from the early writings, of course, we don't have pictures of what they could see with their primitive telescopes. We have replicas of those, and we can look. And those were sufficient for people to look at Mars, which is of interest, has been of interest since ancient times because of its strange retrograde movement across the night sky. But people took a look at something fuzzier than this picture, but they noticed seasonality. Again, clever, careful observations over time, and a mind that models it, they say, that means season. I see this white stuff going up and down, and it looks like every 2 years. It's important to note that at the time that they were looking at that, we did not know about Antarctica, right? And the Flat Earth Society was it at the time. And these nut jobs were looking at another body in the, in the heavens and surmising that there's seasonality. And that leads you to thinking about the inclination of the planets, et cetera. So I wanted to just bring this up because viewpoints are important. So every major society has had one of these fantastical projects that were expensive, difficult to do, but they become their cultural cornerstone. This picture, in my mind, is the cultural cornerstone for the American 20th century. Perhaps for all of Earth's citizens as of 20th century. 20th century was a nasty century. Horrific wars. A lot of problems. But once we see this picture, I think, like Galileo, our mind changes. So the perspective in exploration sometimes gives you surprising results. It's not always that I'm looking for water, I'm going to go there and I'll find water or not find water. On the way, and as you develop tools and techniques in order to build models about the physical world, you run into beautiful surprises. There's an audio of the astronauts on board Apollo 8. And they're scrambling for color film as the Earth is rising. Okay, we all have done that, scrambling, to catch a picture. So in my history of learning things about my universe, these are the characters that have helped me develop my viewpoint. Ptolemy is a great model builder. strange character. He was a Greek guy living in Roman-occupied Egypt, city of Alexandria, that over time created this fantastic library of knowledge. His model was wrong, but for 1,000 years, even longer than the millennium, this was the accepted model of our universe, at least in the Western cultures. Until we get into the time frame of Copernicus, Galileo, Brahe, and Kepler, and with these guys, they fine-tuned the model. There's a name missing from this list, and that's Isaac Newton. His name is too big, it doesn't fit here. So Newton created a model of the solar system based on gravity, and that model very closely correlates with the Kepler model, which was based on observations of the night sky. When two models match, you have it. This is exploration to the best. Paper and pencil, pretty much, but you got it. And then we fast forward to sort of our time frame. Kardashev and Carl Sagan are the people who kind of put it in sociological terms for us, helped us understand how the technology development ties into what we know about our environment. Apollo 11, the culmination of all that work. And this is a Japanese lunar orbiter called Kaguya. If you have not seen the HD videos of this, I suggest that you look it up. It's breathtaking, okay? It's a simple craft with a camera. So if we have good cameras and we know where to place them, we will see images that will blow our minds. And that is the first step in exploration. Develop models that you can explain things. For this picture, the camera is orbiting Mars. This is Mars Reconnaissance Observer taking a picture of Earth. For some reason, wherever we go, we turn the camera back towards Earth. We want to look back home. It's an interesting picture. It appears like the moon and the Earth are closer than they actually are, but this is just 3D perspective, right? You can get, it could be a little deceiving. The contrast they have mucked with, because if Earth is at that contrast level, the moon would be too dark to see. So it's a dynamic range manipulation. But it's a fantastic picture. Another picture of Earth from Mars, taken from a little exploratory camera on the surface of the Gale crater on Mars. So we always come back to home planet. When we talk about Mars exploration, there's been a good family of robotic ships orbiting and landing. Some have failed, many have not. And one interesting thing about this picture is that all these red flags belong to a country that doesn't exist anymore. But their work persists. And that really goes back to that issue of great civilizations and their cultural cornerstones. If you go back in history, the Egyptians developed the pyramids for whatever reason. But to do the pyramids, they had to get really good at geometry. The Persians wanted instant messaging, so they developed the postal system long time ago. In order to get there, they had to domesticate and breed large horses that could carry a man and his Amazon packages and go for a whole day. That horse became military power that kept them for millennia in charge of a good portion of the known world. So postal system, horse, military dominance. The Romans developed this kind of cement in order to build aqueducts. That cement helped them build roads, and that cement lasted them much longer than the Roman Empire did. So this is serious stuff down the road. I think I don't have to preach to the choir here. This is the next step in that work. Yes? Human exploration of Mars. So the three topics I mentioned earlier, let's just talk a little bit about them, because as we talk to others outside of this room, it's important that we have clear, concise answers to these. And I don't claim that I have them, but you guys are going to help me and everybody else develop these. So the first one is always cost, or is it at the expense of projects here? You know, we have problems here. Why do you want to send the money to Mars? And I always give a flip answer that I guarantee you none of it I will send to Mars. We will spend all of it right here with jobs here and technology development here. But the true answer is also that you're replacing resources that should be at the service of our planet, and you're going to do something else with it. But again, one more viewpoint, a picture from ISS. Once we started seeing these images, you realize that our habitat is so fragile. It's just that thin layer of air. That's it. That's all we have. And everything we've done in terms of developing space science, the Apollo program, and now the exploration of the solar system, teaches us how important this one planet is of all the planets around. We know now about a lot of exoplanets. The more we learn about them, the more this one becomes dear and precious to us. So whatever cost. The cost of the Apollo program was $200 billion in today's dollars. Well spent, I think. The next one is this business that evolution created us for this environment. We shouldn't go anywhere else. And you've seen this anthropological infographic with all the funny versions of it, right? And, okay, that speaks for itself. I think the next step on that infographic should be Mark Watney and his descendants, and they may look a little different from us. They may get smaller if they live in a low-gravity environment. Who knows? But that the human exploration phase of this, and Mars being the one planet that happens to be close by, happens to have an atmosphere sufficient for us to do things, unlike the Moon or the other close planet, Venus, that is very difficult to do anything with. To do this kind of exploration, meaning that in our minds, having boots on the ground, on the Martian surface, and eventually in my mind, exploration is not just this boring scientific thing. Science is the tool. Humans on Mars will do poetry. Somebody will pick up a rock and look at it, and it's not interesting. He'll flip it at the helmet of the guy in front of him, boing, ha ha ha. Once we have fun in that, we can get comfortable with the environment that will give us possibly a new home, but more than likely a station for us to do further exploration. So that brings us to this issue. You hear, again, issues of risk. It's risky. It's dangerous. Yes, it is. Right now, our technology to get out of Earth's gravity well is rockets. Rockets don't work all the time. The best rocket building nations and organizations have failure rates that are not acceptable for any other transportation vehicle that I can think of. The rocket is dangerous. We don't have any better technologies yet. I know people in this room who are working on better methods of getting out of the gravity well. Exploration pokes you to develop better tools. And the other issue is, I call this decisions and implications. Sometimes postponing a decision is a decision itself. And it has serious implications. So we have a builder society at this point, globally. We build things. Sometimes useless things, but we build. But imagine we get to the point that the population of the Earth reaches to the point that it matches our resources, all the resources of this planet. Then what are we going to do? We're going to have to step back. We're going to have to resign ourselves to stagnation and quit building so much. It becomes a question of the type of civilization we're going to have. So Kardashev created this three-stage civilization with associated total powers. Basically, in simple terms, the resources of a single planet, the resources of a solar system, and the resources of the galaxy. We may be getting clever enough to put a tick mark on type 1 civilization for ourselves, although in some measures we fail badly. The next step, if it is to be exploration in a larger sense of the solar system, to the point that we can actually extract resources, energy, goods, minerals, that would be our next stepping stone. That's why Mars happens to be so important. I mean, our solar system could have easily been configured such that there is one rocky planet, Earth, and then there are the gas giants. We've looked at enough exosystems now to see that that seems to be pretty common configuration. So we're lucky to have a way station that with sufficient exploration we can get there. So the three topics, remember, who can name the three topics? I have treats. Three times. What's the first one? Is it worth it? Okay. Who said that? Mars or bust. I was wearing one of these yesterday, and I walked over across the road to grab a bite, and everybody commented on the button, and I had two. I gave them. I gave them away. Okay. So question number one is cost, and I think we have reasonably good answers to say the cost is justifiable. It is not a horrendous set of resources, and all those resources are here, creating jobs, and of course we all know about the spin-off technology. So cost, check mark. We can deal with that. What's the second concern?
Risk.
Second one is human biology and our limitations. It is of course related to the risk. But the human biology part, I believe, also has an answer. First of all, we think we were developed for this planet. Really not. 3/4 of this planet is water. We can't live in or underwater. Temporarily, we could put a bunch of guys in a submarine. That, you know. Yeah. You got me. Here, you get one more. Okay. So that's 3/4 of the land. But our ancestors basically were developed for a, say, subtropical environment, you know, edge of a forest. And I know the first guy who said, let's get off the trees and walk the savannah, they made fun of him and hit him with the same things, you know. Ooh, it's too dangerous, you know, it's costly. We're not meant for that, we're meant for this. So that's, yeah, and probably hitting him with a rock was first invented there. But they did, they had to go walk, and as they developed technology, one of the first technologies was domesticating wolves to dogs, and that was critical in colonizing, you know, areas such as Northern Europe. So human biology, we can overcome. We can put Mark Watney in a suit, you know, that he may need duct tape for it, but he can, you know, manage. And that's really the next thing we need to learn, is the low gravity of Mars. The two risks that people talk about is the low gravity on Mars. Can we survive there? Can we have babies there? Is it good for us? Is it, you know, is it going to be detrimental to our health like zero-G is? That's something that we need to explore and find. But it certainly is not going to stop us. The second issue is the radiation that during travel to Mars, solar radiation and cosmic radiation on the surface of Mars, same issues to a lower extent. Can we deal with that? Technology will help us deal with that. As an engineer, I'm pretty sure about that. And the third element is risk, both societal risk and also just rockets blowing up on us, which is real, and we need to figure out if this mission, if this journey is important enough that for us, we're going to go tackle it. And finally, I'm going to show you this favorite picture of mine. If I'm given the camera, I want to put it on top of that mountain. It's a fantastic place to go. Mount Olympus on Mars. It's so big that if you're actually on the top of it, you know, Mars's horizon is narrower because it's a smaller planet. If you're standing on top of that, you don't notice you're on top of a mountain, actually. You see these slopes around you. But it's because the top of it is almost outside Martian atmosphere, it's a great place for doing all kinds of science projects. You know, it's like being in orbit, but you can take the train to it. So that's my suggestion, and that's the presentation. Thank you for being here. I would ask you to, if you have ideas about these three topics, arguments for, against, we need to hone this conversation, make it more precise, more clear. Please email me any ideas that you may have on this topic. Questions?
Kind of the talk earlier this afternoon. What do you think about the cultural implications that may develop on Mars and impact Earth? So, I mean, there may be the argument, you know, that we would be creating two separate streams
right.
of humanity.
So that's an interesting and very complicated topic. But we have already seen that when we open up our eyes and put the camera in different places, our own ideas about ourselves change. In none of those pictures of Earth, I saw borders drawn on, so, it gives you ideas. There's an interesting case I mentioned about the great cultural cornerstones. So for the Europeans, it was the Brits who were an island nation developing these ships that could sail and lose sight of land and enough navigation techniques to do things. They dominated the world based on that technology. They colonized the world, basically. And the corollary to that is the Chinese, 100 years earlier, had a navy that was capable. And they had actually gone through the southern parts of Africa, where they're coming up on the west coast of Africa. Because when the sailors went back, they reported really weird stuff. People of different shape and color, civilizations other than their own, that was deemed bad. So the impact of the people traveling and exploring, coming back home and telling the stories was considered a negative. The court priests burned the fleet because they thought that was too dangerous for their society to handle. Well, a couple hundred years later, the Brits went and colonized China, who had no ships at that point. So yes, ideas coming back from Mars, if the Mars colonists develop as a different culture, they become different shapes, go through physiological changes over 10 or so generations. Now we know about epigenetics. We know that the changes that epigenetics imposes on living beings, like a wolf going to a dog, it's actually a lot faster than what we think. Our thinking was always evolution based on genetic mutation, but epigenetic changes are much faster. A few generations and the people will lose their eye color, paler skin to live in the Northern Europe arena. So we will have these big surprises, I have no doubt. And some of the ideas coming back from Mars, remember the Martians will have to live together and get along because they're going to have a domed society as a model. Those people will have to cooperate. They can't blow up nuclear weapons on each other. It won't work. So when those ideas come back to Earth, I'm sure some of us will consider those dangerous, bad ideas. And we may even cut communications for a while. But overall, it'll be good for us to make that transition to civilization type 2. Go ahead.
How about the overview effect, like the astronauts experience in the orbit when they see the Earth?
So I have limited my thinking and the organization of both the Mars 101 talk and this one to exploration phase, because my mind doesn't expand I can't foresee what that society will develop as. But I know it'll be interesting. No matter how do you do it, it'll be a very interesting. Somebody called Mars the biggest petri dish possible. But what those cultures will look like, who knows? There's a set of good science fiction that discusses that. But for me, I'm looking at the immediate impact of seeing that Apollo 8 picture, right? That one was definitely a cultural change, let's say, globally, everywhere, not just United States. And I think, I know for a fact that if we have people living on Mars, they'll be constantly taking selfies with Earth, behind it. So. Go ahead.
Back in the late 18th century, 1 out of 3 ships that sailed from Europe to the United States and vice versa never made it.
That's right.
We were talking about risk. What is the ratio of failures today?
In rocketry, about 20% of rockets have failures. Not all of them are, detrimental, catastrophic.
So it's actually less risky to go up in this
Than those ships, yes.
than it was a ship.
Absolutely. Absolutely, go ahead.
Small correction. To Mars, it's 50%.
You mentioned that 50%. Okay. Because this is landing or going into orbit around Mars, right? Yeah. Question here?
Yes, what are your thoughts about the issue of if there's life on Mars, what do we do about that?
Right. So at the end of the exploration, the next stage in exploration of Mars, up to now it's been, is there water? I think we've answered that pretty clearly. The next one, was there ancient life on Mars? Is there present life on Mars? And when you find it, you have a lot of head scratching to do, right? There are people that I heard yesterday saying we shouldn't touch it. We shouldn't even go there if we find Mars. contaminating Mars or bringing back pathogens that would contaminate Earth. I think explorers usually defy that. We tend to stick our heads in a beehive to learn about bees. And so I think we need to take precautions. This National Geographic thing about Mars, those people were idiots. They took none of the precautions that you were supposed to do, including having just the one airlock that can destroy your camp. You shouldn't do that as an engineer. But the question of life on Mars is probably the most interesting question in terms of our exploration. And I believe that we need humans there to lift the right rock. More robotic exploration is definitely useful. And as we have humans there, they need the robots. But I don't think we should back off or be afraid of what we find in case there are, in case that we find signs of life today. Go ahead.
When I look at the image of Earthrise,
Yeah.
I see the same thing that you say you see.
That choice will be technocratic, I think. So the Apollo astronauts were picked based on physiology of a test pilot, right? But now we have people going up to the space station that are scientists. So I think we'll have a similar thing. First missions probably test pilot types, and then hopefully quickly after that, scientists. And sometimes, like we have in McMurdo, we'll have a settlement there with scientists that will be sort of self-governing and dealing with issues locally, but doing their exploration. I have no doubt that we'll have Indians and Chinese people competing for this. This is going to be the jewel in the crown of human knowledge. Okay, I'm out of time. I'd be happy to talk to any and all of you. Thank you very much.